YouTube channel. I'm Vikash Sir and I welcome you all to this very important session for RRB JE 2024. So as you know that I have taken 3 sessions in the previous week where I have taken this class of thermodynamics, fluid mechanics and thermodynamics and applications. So we have taken few questions on this. Basically, thermodynamics applications class was not did not take place, but I have taken subject of thermodynamics and fluid mechanics, and I hope you guys have gone through that videos. If you have not, then you can find the recorded videos in the same YouTube channel where I have taken the class of thermodynamics and fluid mechanics. Now today we are going to discuss the previous year questions on thermodynamics subject. Okay, so please everyone quickly join me for this session, and before I start I would like you to please focus on this. Please everyone subscribe the YouTube channel if you have not done yet. Okay, that's very important. If you have not joined the YouTube channel, please subscribe the channel and press the bell icon so that you don't miss any videos from our YouTube channel. Okay, just a second. Hello everyone. Yes, hello Anas, Vikas and MS. Good evening, welcome to the session. Just a second. Just a second everyone. I hope the audio video is fine. So guys, just a second. Yeah. So if you have not yet subscribed the channel and like the session, then please do it. And also do not forget to share the session also. Class cannot be taken in Hindi because we have planned the classes as such in English so that all the students from entire country who are preparing for RRB JE can get benefit from these classes. And as you know that Hindi is not a language which sadly everyone understand, right? So most of the students understand English in entire country. So that's why I have to teach in English. Okay. So that everyone can attend the classes. Although the number is quite less, I can see very less students live in the class. Okay, and I request everyone to please like and share the session. I'm coming after after a long time, but I think Suraj sir was taking the classes. After I have taken 2 classes, Suraj sir has taken the classes, and I hope you have enjoyed those sessions and learned the concept from Suraj sir as well. My dear students, this is all a small introduction about me, and my telegram is mechanical by Vikas, and Vikas at the rate resultant.in is my mail ID where you can mail me if you are having any query. Also, my dear students, if you want to know about my teaching experience and all other things, then you can see everything is written over here. These are the subjects that I generally teach. Okay. Very important thing I want to tell you that, as you know that Resultant AJE has started courses for RRB JE, right? And if any students is interested to basically join our course, as you know, Independence Day is there on 15th of August. So on occasion of Independence Day, we are providing discount of around 55%. As you can see, 55% off on our courses. Okay, whether you are preparing for RRB JE on either or any other exam like GATE or engineering services. So we are providing this discount of 55%. You just have to use India 55 code. This is valid only from 14th to 16th of August. Okay, so one day before Independence Day, right? And one day after Independence Day, complete for 3 days. This will be valid. You can use this code and you can get 55% discount on our courses. These are the faculties who will be taking the classes on our courses. Dheeraj Sardana sir, Vikas, that is me, Chandrasekhar sir, and Suraj Gopi sir. Okay, and let me tell you about our courses. We are currently providing 3 types of courses. One is for RRB JE CBD1, which is known as Focus Batch. Okay, whose cost you can see right now is 2499 offer price. RRB JE CBD2, which is completely for which is called AIM batch. It is for CBD2 of RRB JE. The cost is this, discounted price is this, and this is the MRP price. And we have a combined batch for CBD1 and CBD2, which is called Mission batch. Okay, the cost discounted price is this right now, but MRP will be this price. Okay, so I hope the audio video is fine. Everyone, please quickly join me for this session. एक बार yes. एक बार मुझे brief कर देंगे everyone that my audio video is fine or not. And if you are having any query regarding our courses, you can just give a call on this number. Okay, and you can also mail us here support@resultant.in. All right, and you can see the information about our AIM batch for CBD2, which is a technical batch for technical, that is mechanical. This is a recorded batch and live batch. Completely live and recorded classes will be provided to you in English, and these will be the faculties. Okay, also we have a mission batch which is for CBT1 CBT2 combined, and these are the faculties. Let's come to first question, question number 1. Yes, I request everyone to join the class, and if you will not join the classes, then how yeah, I know that I am coming to take this class after I think 2 or 3 days, so I request everyone. I think already I have shared the class, but request everyone to please quickly share the session. Okay, which of the following is an exothermic process? Exothermic means, exothermic is energy is released. These are all previous year question on thermodynamics subject. Energy is released. Okay, released. Energy is released from the process. Which of the following will be exothermic process? The answer is option number D, which is reaction of water with fixed lime. Because this reaction, when water will interact with the lime, then the energy will be released. Although all the other process like sublimation, evaporation, these two are endothermic process in which energy is supplied. Energy is supplied, that is energy is absorbed. When energy is absorbed, it is called as endothermic process. When energy is released, it is called exothermic process. Okay. When the state is being changed from gas to liquid through the process of condensation, then what happens to temperature? When state changes from gas to liquid, actually this is not absolutely correct, because we cannot say gas is changing its phase. Actually vapor changes its phase from phase to liquid. Okay, so whenever phase change take place from vapor to liquid, then this process called as when vapor to liquid take place, then this is called as condensation. This is called as condensation. And that during condensation, the pressure as well as temperature remains constant. So what happened to temperature? The temperature will remain constant during the condensation process. Again, I'm telling you, these are thermodynamics previous year questions. So RRB JE previous year question of thermodynamics. Please keep a note of this. If this question looks easy to you, that doesn't mean that I have deliberately chosen this question. These are all previous year questions of thermodynamics subject. The specific heat at constant volume of solids obeys Davy's temperature cube law, that is temperature power 3 law. Okay, this is called Davy's law. But this Davy's law is valid up to at high temperature, at low temperature, at high pressure, or at all temperature. Yes, tell me. The Davy's law is applicable for solids at low temperature. This is basically given for low temperature. I think there is some problem because students are not responding. Any issue in the class? Please let me know. Just a second. Because students are not responding in this chat box, or there are only 3 students watching. Yeah, thank you so much for your great response. And if that is a big number that we are seeing right now, it's not the number I expect. Yeah, just a second. What has just happened? Yeah, any problem in the session? आपको कोई प्रॉब्लम है सेशन में? चलिए हिंदी में 1 मिनट बात कर लेते हैं. एनी प्रॉब्लम इन द सेशन? आप लोग सेशन में नहीं आ रहे हैं, क्लास अटेंड नहीं कर रहे हैं, तो किसी प्रकार की समस्या परेशानी? एनी प्रॉब्लम इन द सेशन प्लीज लेट मी नो. देखिए, कोई चीज़ अगर आपको इंग्लिश में समझ में नहीं आती, आई कैन एक्सप्लेन इन हिंदी, दैट्स नॉट अ प्रॉब्लम, दैट्स नॉट अ इशू. But not attending the classes that are basically provided to you, that is absolutely free classes. Okay. And one more thing I must tell you about myself. I have again started teaching on this platform, and initially I thought I will never teach now. Okay. And it's not something that I have to say on YouTube, but there was a lot of request by many students. Sir, we want your lectures. So I have joined this particular platform. But if you will not attend the classes, if you will not value these classes, then I will definitely regret my decision of coming back. Okay. I don't know why you are not coming to the classes, because we are only providing one mechanical class at 8 p.m. Okay, and that too is not being attended. I don't understand. So request everyone to please follow the classes, follow the session. If you will not follow the classes, then I must tell you that there will be many faculties on the YouTube, but I will not teach you. If you really want my lectures, right, after you guys have requested so much that, sir, we want you to teach us, whether you join any platform or you teach at your own platform. But when I have finally joined a platform to teach you guys, you are not coming to the classes. If these are the 5 students who are preparing for some examination, whether it is SSC JCBT2 or RRB JCBT2, that number is very varying for us. सिर्फ 5 लोग अगर तैयारी कर रहे हैं मैकेनिकल से, तो ये तो बहुत ही, इट्स वेरी बैड नंबर, आई थिंक. नेक्स्ट क्वेश्चन. 2 gases X and Y having same temperature T, the pressure P and the same volume V are mixed. If the mixture has a volume V and temperature T, then pressure of the mixture will be. How you will solve this question? सी मैं बोल सकता हूँ हिंदी में एक बार फिर से, आई हैव नो प्रॉब्लम. but it is decided by our team only that we will not be teaching in Hindi. Okay, so okay, if you want I can discuss that if we can do that. Okay, अगर ऐसा कर सकते हैं कि हम हिंदी में एक बार और बोल सकते हैं तो मैं कर सकता हूँ. आई कैन गिव माई, एक लाइन इंग्लिश एक लाइन हिंदी में बोल सकता हूँ, ये कोई दिक्कत नहीं. यस, टू गैसेस एक्स एंड वाई. लेट्स से वी हैव गैस एक्स एंड गैस वाई. ओके, हमारे पास दो गैस हैं, एक तरफ है गैस एक्स, अनदर इज गैस वाई. ओके, now having same temperature T and pressure P and same volume, so both the gases have same pressure, volume and temperature. Pressure, volume and temperature is same. Okay, next is a mixture. So what we are doing here, we are mixing both the gases. If we combine with the gases, then pressure the mixture will. Do you know what is Dalton's law? Do you remember Dalton's law? Dalton's law says that when you mix these two gases and you combine them in a single container, then total pressure after mixing will become sum of the initial pressure, that is P plus P, which is 2P. So pressure will become twice. Okay, so the answer will be option B. Next question. समझ में आ गया सभी को? क्या आप सभी को समझ में आ गया कि हमने यहाँ पे Dalton's law अप्लाई किया है? We have applied the Dalton's law. And to all the students who understand English and Hindi, I am repeating it again. दो गैसेस थी एक्स एंड वाई, इनका प्रेशर वॉल्यूम टेम्परेचर आपका सेम दिया हुआ था, दैट इज सेम पीबीटी. ओके, बट यू नो द व्हाट इज डाल्टन्स लॉ. एट सेम टेम्परेचर एंड वॉल्यूम ऑल द गैस, इफ यू mix the total pressure of the mixture of gases equal to sum of individual pressure. Okay, टोटल प्रेशर क्या हो जाता है? इंडिविजुअल प्रेशर का सम, क्योंकि इनका गैसेस का इंडिविजुअल प्रेशर इज पी एंड पी, सो विल एड इट विल बिकम 2p. ओके, नेक्स्ट, द इंटरनल एनर्जी ऑफ अ परफेक्ट गैस डज नॉट चेंज ड्यूरिंग द. परफेक्ट गैस की जो इंटरनल एनर्जी है वो चेंज नहीं होती है. कब चेंज नहीं होती है? द इंटरनल एनर्जी ऑफ परफेक्ट गैस डज नॉट चेंज ड्यूरिंग द आइसोकोरिक, आइसोथर्मल, एडियाबैटिक, आइसोबैरिक प्रोसेस. द करेक्ट आंसर विल बी ऑप्शन बी. एज यू नो दैट, हमने ये पहले भी पढ़ा हुआ है कि कांस्टेंट टेम्परेचर प्रोसेस यानी आइसोथर्मल प्रोसेस के अंदर, इन आइसोथर्मल प्रोसेस सिंस टेम्परेचर इज केप्ट कांस्टेंट, सो इन दैट सिचुएशन द चेंज इन टेम्परेचर विल बिकम जीरो. इन दैट सिचुएशन जो इंटरनल एनर्जी का चेंज होता है क्या होता है? mCv/dt, है ना? सो उस केस में ये जीरो हो जाएगा. ओके, इंटरनल एनर्जी चेंज विल बी जीरो, दैट मीन्स इंटरनल एनर्जी विल बी कांस्टेंट. क्लियर? द आंसर विल बी आइसोथर्मल प्रोसेस. नेक्स्ट क्वेश्चन. A sample of ideal gas has an internal energy U and is compressed to 1/2 of its original volume, while the temperature stays the same. What is the new internal energy of the ideal gas in terms of U? So होता क्या है? As you know that temperature remains same. Temperature stays same for ideal gas. For ideal gas, अगर temperature constant है, temperature remains same. That is, it is an isothermal process. It is an isothermal process. और अगर isothermal process है तो situation में what will happen? We have just seen. Then internal energy change will be zero. That is final minus initial internal energy change will be zero. Initial internal energy will be equal to final internal energy. दोनों इक्वल हो जाएगा. और किसके इक्वल है? आपके U के इक्वल हो जाएगा. तो क्या रहेगा आपका? Internal energy will remain U. It will remain same. Okay? Clear to everyone? Next question. Which one of the following is a steady flow energy equation for a boiler? Boiler की steady flow energy equation इनमें से कौन सी है? So we know that what is steady flow energy equation. आपको पता है क्या होता है steady flow energy equation? Do you know this? We have studied this. क्या होती है? It is m into h1 plus v1 square by 2000. अब इसको तो हिंदी में नहीं बोलूंगा मैं, राइट? दिस वी हैव टू स्टडी इन इंग्लिश. हाय पुष्पिन, गुड इवनिंग, कैसे हैं आप? वेलकम टू द सेशन. सो प्लीज टेल मी इफ माय ऑडियो एंड वीडियो इज क्लियर एंड यू गाइज सी. आई हैव ऑलरेडी टोल्ड यू इन द लास्ट क्लास ऑन वेडनेसडे कि अब मैं आपसे नेक्स्ट मिलूंगा मंडे को, बट आई थिंक माई स्टूडेंट्स मस्ट हैव बीन मैं सोचा था मेरे स्टूडेंट मेरा वेट करेंगे, बट यहाँ तो मैं देख रहा हूँ 5 स्टूडेंट्स ही रह गए हैं. I think after 1 week again when I will come, I will see only 1 student in the class. अगर आप ऐसा करेंगे तो बहुत ही गलत बात है. So as you know that we follow some assumptions, few assumptions for a boiler, right? Boilers works under some assumption, that is, first assumption is that we don't have any work in the boiler. We don't get any work from the boiler. Second assumption is that the changes in kinetic energy and potential energy are zero. किसी प्रकार का kinetic and potential energy का change नहीं होता boiler में. So in that situation ये zero हो जाएगा, ये zero हो जाएगा, this will be zero, this will be zero, this will be zero, right? What are we going to get here? We get that Q is equal to M H2 minus H1. This is the total heat supplied. Okay, so this is the answer for this question, that is option B only. Clear to everyone? सबको समझ में आ गया? Hello Souvik. Souvik, good evening, welcome to the session. Next question. The heat interaction of the system is a function of temperature only, which is given by this equation. Can you see this? 30 plus 1, 30 plus, I think it is not 1, it is T. Temperature is T. If the system does a work of 2 kilojoule per Kelvin, what is the increase in internal energy per degree temperature? इस क्वेश्चन के अंदर आपको कह रहा है कि जो हीट है वो टेम्परेचर का फंक्शन है, और कैसे दे रखा है? इट इज 30 प्लस टी किलो जूल, वेयर टी इज द टेम्परेचर नॉट टाइम. ओके, अंडरस्टैंड. एंड ऑल्सो दे हैव गिवन द इंक्रीज इन वर्क. वर्क जो दे रखा है आपको, द वर्क इज विथ रिस्पेक्ट टू टेम्परेचर नॉट टाइम. इट इज टेम्परेचर 2 किलोजूल पर केल्विन. You have to find the increase in internal energy per degree temperature. Okay, du by dt you have to get. कैसे फाइंड करेंगे आप? Q minus W is equal to du, है ना? Right? So here Q you have to find, because work आपको टेम्परेचर के फॉर्म में दे रखा है, तो हीट को भी हमें, for heat also we need to find it in terms of temperature. So that will be 30 plus T, that is 1. You will get this as 1. When you divide T by dt, dq by dt, you will get 1. So this will be 1 minus 2 is equal to du. तो du कितना हो जाएगा आपका, बताइए? du will be equal to 1 minus 2, that is minus 1. वैसे तो minus 1 आना चाहिए. System does work, heat interaction is a function of temperature. I think either there is a mistake. There is a mistake in the question. Because यहाँ पर ये कह रहे हैं, they are saying that it is increase in internal energy, so it has to be positive, but by calculation it is not coming out to be positive. यहाँ पर ऐसा नहीं हो सकता. Q minus W, yeah, first law of thermodynamics तो यही है, Q minus W is equal to du, or we can say dq by dt minus dw by dt. तो यहाँ पे जो वर्क है वो आपको सिस्टम डज द वर्क, इट इज पॉजिटिव, and dq by dt is already positive. Only thing that may be wrong here, if it is really increased, तो ये माइनस होना चाहिए, या तो ये माइनस होना चाहिए, राइट, या तो ये माइनस होना चाहिए, तभी आपका ये आंसर आ सकता है, राइट. अदरवाइज यू विल, बट माइनस होने पे भी आंसर नहीं आएगा. नो 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 नो, इट विल नॉट बी माइनस. There is some mistake here. There is some mistake definitely. इस तरीके से मिस्टेक भी हो जाती है आपको. ये आई थिंक -1 आना चाहिए. ये इसका आंसर ऑप्शन ए आएगा. इंक्रीज इन, it is, they are definitely saying increase, but it is not actually increase, it is decreasing. Okay, next, which equation is the correct representation of the process shown below? आप यहां पर देख सकते हैं एक प्रोसेस है 1 से 2 थ्रू पाथ ए, दिस इज पाथ ए, एंड अनदर प्रोसेस 2 to 1 थ्रू पाथ बी, दिस इज पाथ बी. ओके, you have to find, see, if you see 1 to 2 and then 2 to 1, it is definitely completing a cycle, it is forming a cycle, thermodynamic cycle. And for a cycle, according to first law of thermodynamics, what is first law of thermodynamics for a cycle? Tell me. First law of thermodynamics for a cycle क्या होता है, बताइए सभी लोग. Tell me everyone, what is first law of thermodynamics for a cycle? Net heat transfer is equal to net work transfer. Net heat transfer for the cycle will be Q1A2 plus Q2B1. Net work transfer will be W1A2 plus W2B1. ओके तो क्या हो जाएगा इस क्वेश्चन का आंसर बताइए? I think it is not written in the written correctly, but this should be the answer. 1A2, it has to be written 1A2, but it is written A12, B21. Okay, but Q, you have to add the Q and you have to add the work. Okay, so this will be plus sign. The right answer will be option C. Okay, clear to everyone? So basically what they have done is, instead of writing 1A2, they are writing A12. Instead of writing 2B1, they are writing B21. Okay, clear? समझ में आ रहा सभी को क्वेश्चन? These are all previous year question of RRB JE. Okay. Next, which equation clearly defines the entropy change during constant pressure process for a system with m kg of gas at pressure P1, volume V1, temperature T1, and entropy S1 when heated to state points of pressure P2, volume V2 and temperature T2 and entropy S2. बेसिकली ये कहना चाहते हैं कि आपको एंट्रोपी चेंज बताना है कांस्टेंट प्रेशर प्रोसेस के लिए. आप क्या लिखेंगे? सो यू नो दैट व्हाट इज द इक्वेशन फॉर एंट्रोपी चेंज. इक्वेशन फॉर एंट्रोपी चेंज क्या होती है? इट इज mCp log of T2 by T1 माइनस mR log of P2 by P1. एक तो ये इक्वेशन होती है माय डियर स्टूडेंट्स. एक इक्वेशन आपकी ये भी होती है S2 minus S1 is equal to mCv log of T2 by T1 plus mR log of V2 by V1. This is one more equation. अब यहां पर कौन सी इक्वेशन होगी ये तो नहीं पता, बट हमें ये चीज जरूर पता है कि कांस्टेंट प्रेशर प्रोसेस इज मेंशन्ड हियर माय डियर. So for constant pressure process, if pressure is constant, pressure same है अगर, if it is constant, then log P1 by P2, sorry, P2 by P1 will be equal to log 1, and log 1 is equal to 0, so this will be 0, right? So if this will be 0, the answer will come out to be option number B, mCp log of T2 by T1. एक और आंसर हो सकता है mCp log T2 by T1, बट seeing this particular condition, क्योंकि ये वाला इक्वेशन नहीं हो सकता, दिस कैन नॉट बी द आंसर बिकॉज ये कंप्लीट इक्वेशन तो यहां पर दे नहीं रखी है. दे हैव नॉट गिवन द कंप्लीट इक्वेशन, राइट? दे हैव आइदर गिवन mR log V2 by V1, और ये तभी हो सकता है व्हेन टेम्परेचर इज केप्ट कांस्टेंट. अगर टेम्परेचर सेम हो जाता, इफ T1 इज इक्वल टू T2 होता, तो इसका ये 0 हो जाता, तब ये आंसर होता. आर यू गेटिंग माय पॉइंट? ओके, सो द राइट आंसर विल बी mCp log T2 by T1. और ये कब होता? जब वॉल्यूम सेम हो जाता, तब ये आंसर होता है. ये आंसर कब होता? व्हेन टेम्परेचर वुड हैव बीन सेम, देन दिस वुड हैव बीन द आंसर. क्लियर? इज इट क्लियर टू ऑल ऑफ यू? टेल मी. And this equation, my dear, this is equation for polytropic process. For polytropic process, if we have to find the entropy change, then this option D will be the answer. Okay. Next question: an engine working on Stirling cycle between the same temperature limits as that of Carnot cycle has air standard efficiency. So basically, they are saying that we have a Stirling cycle and we have a Carnot cycle, and both Stirling and Carnot are working between same temperature. Let's say both are working same high and low temperature. Both are reversible cycle and both working between same temperature, high and low temperature. Okay. So you know what is Carnot principle? If two reversible cycle works between same temperature, then their efficiency depends only on the temperature, right? Clear? So it will be efficiency will be equal to Carnot. Efficiency of the Stirling cycle will depend only on temperature, so they will be equal. Efficiency of the Carnot will be equal to efficiency of the Stirling. इनकी efficiency equal हो जाएगी, it will be equal, that will be equal to 1 minus lower by higher temperature. Clear? Next question, during a process on the closed system, its internal energy increases by twice the units than the heat added to it. It is possible due to. इस क्वेश्चन में कहा जा रहा है कि एक क्लोज सिस्टम का प्रोसेस है जिसमें इंटरनल एनर्जी इज इंक्रीजिंग ट्वाइस द यूनिट्स देन द हीट एडेड, यानी कि लेट से हीट एडेड कितना है आपका, हीट एडेड इज इक्वल टू Q, एंड व्हाट वी आर डूइंग हियर इज द इंटरनल एनर्जी इज इंक्रीजिंग बाय ट्वाइस द यूनिट्स द हीट एडेड. सो इंटरनल एनर्जी कितना हो गया, इंटरनल एनर्जी इज इक्वल टू internal energy is equal to twice the heat, that is 2 times of heat. क्लियर? आपको इंग्लिश में समझ में नहीं आ रहा तो हिंदी में समझा देता हूं कि एक प्रोसेस है जिसके अंदर इंटरनल एनर्जी इट इज इंक्रीजिंग, बढ़ रही है, इंक्रीज हो रही है बाय ट्वाइस द यूनिट्स, 2 गुना, ट्वाइस द यूनिट्स एंड द हीट एडेड टू इट. ओके, इट इज पॉसिबल. हाउ इट इज पॉसिबल, ऐसा कैसे हो सकता है, हाउ इज इट पॉसिबल, टेल मी एवरीवन. So we know first law of thermodynamics. First law of thermodynamics. I think everybody knows that, right? So according to first law of thermodynamics, what we know is Q, that is heat supplied minus work done, is equal to change in internal energy. So minus of work done is equal to du minus Q. So minus of work done will be equal to du. Du is equal to how much? Tell me. It is 2 into Q minus Q. That will be Q. So we can say work will be equal to minus of Q. यानी work will be equal to minus, negative. Work is negative का मतलब क्या होता है? That is, you can increase the internal energy twice the heat supplied, but only if the work is done on the system. वर्क इज डन ऑन द सिस्टम. अगर सिस्टम के ऊपर वर्क किया जाएगा तभी आप इंटरनल एनर्जी को 2 टाइम्स इंक्रीज कर सकते हैं. यू कैन इंक्रीज द इंटरनल एनर्जी ट्वाइस द हीट, राइट? आर यू एबल टू अंडरस्टैंड एवरीवन? टेल मी. नेक्स्ट, a Carnot engine, not cannot, it is Carnot engine, rejects 40% of the heat absorbed from a source to sink at 27 degrees Celsius. What is the value of source temperature in degrees Celsius? See, these are very simple questions, but they are all previous year questions. Okay, so I think they are not tough. You guys can easily attempt the question, solve it. Rejects, how much heat is getting rejected by the Carnot engine? It rejects 40% of heat absorbed. Clear? So can you find the efficiency? Efficiency will be 1 minus heat rejected by heat supplied. ये होता है फॉर्मूला. So what you will get from here? You will get 1 minus 40 by 100. This will be 60%. The efficiency will be equal to 60%. Now sink temperature. Sink temperature is given in degrees Celsius, which is 300 Kelvin. Efficiency of the Carnot engine can also be written in terms of temperature. 1 minus lower temperature by higher temperature. क्योंकि efficiency you have got 0.6, 60%, then it is 1 minus lower temperature is 300 Kelvin over higher temperature. From here you can get the higher temperature, and after getting higher temperature in Kelvin, you will get in Kelvin, right? So tell me what is the answer? So if you find this higher temperature in Kelvin, you will get high temperature in Kelvin will be 750 Kelvin. 750 Kelvin हो जाएगा, which but they are asking the answer in degrees Celsius, right? So this will be 477 degrees Celsius. Okay, and guys, you can use calculator because if you are preparing for RRB JE CBD2, then calculator is allowed. So you can use your calculator for fast calculation. Okay, calculator is allowed for RRB JE and SSC JE CBD2. तो आप कैलकुलेटर को यूज कर सकते हैं. ओके, नेक्स्ट क्वेश्चन. इफ टू लिक्विड्स एट डिफरेंट टेम्परेचर आर मिक्स्ड, देन फाइनल टेम्परेचर ऑफ द मिक्सचर ऑफ लिक्विड्स कैन बी ऑब्टेन्ड बाय यूजिंग. दो लिक्विड्स हैं, इनके इनिशियल टेम्परेचर, सी दो लिक्विड्स डिफरेंट टेम्परेचर पे हैं. सो लेट्स से वी हैव अ ग्लास. दिस ग्लास इज कंटेनिंग वाटर विच इज वेरी hot water, right? And it is at temperature T1. We have another glass, and that glass is containing cold water or normal water, let's say, right? It is normal water which is at temperature of T2. So what we are going to do is we are going to mix these two, and the resultant will be also both at different temperature. Let's say T1 is more than T2. So what will happen? The final temperature of the mixture of liquids, if you mix these two water, दोनों water को mix करते हैं, then final temperature you can obtain by using first law of thermodynamics. First law of thermodynamics. Because we are not specifying the final temperature, we are obtaining the final temperature. हम final temperature obtain कर रहे हैं. The meaning of obtaining is calculating. That is, we are trying to calculate the final temperature. We are क्वेश्चन में पूछा गया है हाउ यू ऑब्टेन. ऑब्टेन मींस हाउ यू कैलकुलेट द फाइनल टेम्परेचर ऑफ द मिक्सचर. द फाइनल टेम्परेचर ऑफ द मिक्सचर विल बी कैलकुलेटेड यूजिंग फर्स्ट लॉ ऑफ थर्मोडायनामिक्स, राइट? बट इट इज दैट फाइनल टेम्परेचर, सी आफ्टर मिक्सिंग व्हाट विल हैपन, आफ्टर मिक्सिंग both liquids reaches a final equilibrium temperature. किस पे पहुंच जाएंगे दोनों लिक्विड? a final equilibrium temperature which is specified by zeroth law and calculated by first law. Is it clear? Clear to everyone or not? Tell me quickly, everyone. Those who have not liked the session after coming live in the class, please do not forget to like it and share the session as well. You can share the session in your WhatsApp, in your Telegram, wherever you find the people like who are preparing for some examination, whether it is RRB JE, SSC JE, any technical examination where mechanical engineering will be asked. Okay, question will be asked from mechanical engineering subject, so you can share this session with those students. In a Carnot engine, when the working substance gives heat to the sink, Carnot engine working substance is giving heat to the sink. So what is happening in the Carnot engine? We have a source of heat which is supplying the heat. We have a sink which is जिसको heat reject करी जाती है, to whom the heat is getting rejected by the Carnot engine, right? So what is being mentioned here? It is mentioned that कि जब आप heat supply करते हैं, जब heat देते हैं सिंक को, स्पेसिफाइड का मतलब क्या होता है? अच्छा, ये तो वही बात हो गई कि आपका डेट ऑफ बर्थ क्या है. योर डेट ऑफ बर्थ इज स्पेसिफाइड एज, लेट्स से माय डेट ऑफ बर्थ इज 11th Feb 1991. बट इफ आई आस्क यू, ओके, कैलकुलेट माय एज, राइट? आई एम स्पेसिफाइंग माय, see, example of this question is, let's say my date of birth is 11th Feb 1991. This is my date of birth. It is specified as this. ये मैंने स्पेसिफाई किया गया है मेरी डेट ऑफ बर्थ, ठीक है? Now I'm asking you, okay, then MS, calculate my age. Or can you obtain my age from above data? Yes, you can. You can obtain my age by using the data of date of birth. So my date of birth is specified as per whatever time I have, or the day I have been born. But if you have to calculate my age, then you have to calculate as per the current date, right? Today is 12th of August 2024. So with respect to current age, you have to calculate my age. So that is the meaning of calculation. This is the meaning of specification. Clear? समझ में आया? आपको स्पेसिफाई करना अलग चीज होती है और कैलकुलेट करना अलग चीज होती है. Now, as you know that what is in Carnot engine, these two are called as thermal energy reservoir. They are called as thermal energy reservoir. इनको क्या कहा जाता है? Thermal energy reservoir. And what is special about these thermal energy reservoirs? The special about them is no matter how much heat you take from the source and how much heat you give to the sink, their temperature are going to remain constant. इनका टेम्परेचर क्या होगा? कांस्टेंट रहेगा. Their temperature will be constant. Right? Are you getting this? So will the temperature sink will increase or decrease? No. Temperature sink will remain same. Because they are thermal energy reservoir which have infinite heat capacity. No matter how much heat you take from them or give to them, their temperature will remain same. Clear? Is it clear to everyone? For a steady flow system where kinetic and potential energies are negligible, then what will be the first law of thermodynamics? Steady flow system means we are talking about open system, right? Because whenever you see the word flow, flow means open system where mass can flow, and mass कहाँ पे flow करता है? Where mass flow take place? In open system. And for open system under steady flow conditions, the first law of thermodynamics, my friend, you study is this: mh1 plus v1 square by 2000. This is the sum of enthalpy plus kinetic energy plus potential energy, right? Specified in terms of kilojoule per kg. This is heat is equal to mass. Same energy at the exit also, because it is conservation of energy, right? Conservation of energy apply करेंगे ना? बताइए. Tell me everyone. So, क्या बोला गया इस क्वेश्चन में? Neglecting the kinetic and potential energy. You have to neglect the kinetic energy and potential energy. Just neglect them. क्या बन जाएगा? आपको क्या मिलेगा? Tell me. What you will get from here? You will get m h1 minus h2 is equal to plus q is equal to work. Right? Or you can say, my friend, q minus w is equal to m h2 minus h1. Or you can say this is nothing but it is equal to delta H. It is Q minus W is equal to delta H. Clear? कुछ बात समझ में आती है आप लोगों को? Do you understand? So this will be the answer for this particular question. But my friends, अगर आपसे पूछा जाए कि यही सेम चीज क्लोज सिस्टम के लिए कही जाए, if the same thing is mentioned about the closed system, then the first law of thermodynamics will be option number C. Q minus W is equal to change in internal energy. For a closed system where kinetic and potential energy are negligible, then the first law of thermodynamics states that difference between the heat supplied to the system minus work done by system is equal to change in internal energy. तो ये आपके closed system के लिए होता है, ये आपके steady flow system के लिए होता है if the kinetic and potential energy are neglected. Clear to everyone or not? Next, a real gas having positive Joule-Thomson coefficient. If it is throttle, then what will happen to the temperature? It will become warm, cool, same temperature, or higher or warmer. It will be higher, warmer or cooler depending on, I think there is some mistake here. This will be warmer or cooler depending upon composition of gas. So first of all, option D is incorrect. Why? Because it is already mentioned it is a real gas. Now, let me tell you about this Joule-Thomson experiment. Joule-Thomson experiment में क्या किया गया? Real gas की throttling करी गई. Real gas was throttle. Okay? The experiment done by Joule and Thomson, Kelvin Thomson, इन दैट एक्सपेरिमेंट द रियल गैस वाज थ्रॉटलिंग प्रोसेस किया गया रियल गैस के ऊपर, एंड दिस काइंड ऑफ कर्व वाज ऑब्टेन. Okay, these are the throttling curves. Okay, when the real gas, and how you do throttling, you decrease the pressure. Pressure को decrease करते हैं. तो pressure को decrease किया हमने. Now what we observe that this is a point of maximum temperature. This is a point of maximum temperature when you are decreasing the pressure. And if you join this maximum temperature line, you get a line. This line is nothing but a curve which is called इन्वर्जन कर्व. इसको इन्वर्जन कर्व कहा जाता है. मैं पीडीएफ देते हैं क्लास का. आई थिंक मे बी आई हैव मिस्ड द 2 PDFs. आई विल शेयर द PDF टुडे. ओके, डोंट वरी. This is the region where Joule-Thomson coefficient is negative, and this is the region where Joule-Thomson coefficient is positive. Real gas having positive Joule-Thomson coefficient. अगर उसको थ्रॉटलिंग करा जाएगा और थ्रॉटलिंग करेंगे तो क्या होगा, वो और ठंडा हो जाएगा. इट विल बिकम मोर कूलर बिकॉज Joule-Thomson coefficient is equal to, this is Joule-Thomson coefficient is equal to change in temperature with respect to change in pressure at constant enthalpy. And this value will be positive. ये positive कब होगा? When both temperature change and pressure change are negative. So if both pressure and temperature change are negative and you are further doing throttling, so the gas will become more cooler. Clear? It will become cooler. Clear everyone? सबको समझ में आ गया बात? Yes. According to Kelvin-Planck statement, this is a statement of second law of thermodynamics. Second law of thermodynamics, we study 2 types of statement. One is Kelvin-Planck, which talks about the heat engine. Other is Clausius, talks about refrigerator and heat pump. Right? Second law of thermodynamics 2 statement. This is a very important statement. Kelvin-Planck statement क्या कहता है? What does Kelvin statement tells us? It is impossible to construct a device which operates in a cycle and produces no effect other than. I think my typing, the person who has typed the session, these questions have done some mistake, and there is also my mistake that I have not verified these questions. No problem. The first statement is not correct, and it is impossible for a heat engine to produce net work in a complete cycle if it exchanges heat only with body at a single fixed temperature. This is Kelvin-Planck statement. This is also called a negative statement. ये कहता है कि ये इम्पॉसिबल है कि कोई भी हीट इंजन एक सिंगल फिक्स टेम्परेचर रिजर्वायर के साथ हीट एक्सचेंज करे और उस हीट को पूरी तरीके से वर्क में कन्वर्ट कर दे. दिस इज इम्पॉसिबल. बेसिकली इट टेल्स अस दैट द डिवाइस विच वी से PMM2 इज नॉट पॉसिबल. दिस PMM2 इज कन्वर्टिंग दिस हीट फ्रॉम अ सिंगल रिजर्वायर, single fixed temperature reservoir, okay, which is called as source, and it is converting entire heat into work. This is called PMM2, and that PMM2 is impossible according to Kelvin-Planck statement. So option B is the right answer. A pump handling a liquid raises its pressure from 1 bar to 30 bar. एक पंप लिक्विड को हैंडल कर रहा है और प्रेशर को 1 बार से 30 बार ले जाता है. इट increases the pressure from 1 bar to 30 bar. What is the isentropic specific work done by the pump in kilojoule per kg? In this particular question, the density of the liquid is given as 990 kg per meter cube. So first of all, you need to understand what is the meaning of isentropic work. Isentropic work of pump is equal to minus of VdP, right? Because pump is an open system, so open system work को इस तरीके से find करेंगे. It is a steady flow system. Pump एक steady flow system है. It is a steady flow system. So this is how you calculate the work of a steady flow system. But my dear students, since specific volume is not given, mentioned in the question, so let's say minus sign outside, it will be dP by rho. Why rho? Because we know that specific volume is equal to 1 by density. Density का reciprocal होता है. Yeah, density is the reciprocal of specific volume, right? So you can say it is minus of dP is change in pressure, that is 30 minus 1. But because the answer is required in kilojoule, So you have to multiply with 100 because 1 bar is equal to 100 kilopascal. So we have to convert the pressure in kilopascal because we want the answer in kilojoule per kg, right? So that is why we have to convert into kilopascal. So multiply by 100, divide by 990. Solve it, you will get the answer. That is minus 2.93. माइनस साइन को हम इग्नोर कर सकते हैं. रीजन बिकॉज पंप वर्क तो नेगेटिव होता ही है. सो वाई टू, मतलब माइनस साइन बेसिकली इंडिकेट्स पंप वर्क इज नेगेटिव. ओके, इज इट क्लियर टू एवरीवन? Alright, so if it is clear to all of you, just a second, if I think I have some mistake. So 2.93, are you all getting this value? 2.93. Next question. While working as a heat engine, the efficiency is 40%. If the cycle is reversed and made into a heat pump, what is the COP of the heat pump? Understood question or not? So basically we are having a heat engine. Efficiency of the heat engine is, कितना दे रखा है efficiency of the heat engine? It is given as 40%, that is 0.4. Okay. If the cycle is reversed and made into a heat pump, what is the COP? The COP of the heat pump and efficiency of the heat engine are related in this manner. So basically COP of the heat pump is basically reciprocal of the efficiency of the heat engine. So just do a reciprocal of this, you will get the answer. Okay, clear? Isothermal and adiabatic process are identical at. Isothermal process is a process where temperature is constant. Adiabatic process is a process in which heat transfer is zero. And आप लोगों ने पढ़ा है कि these two processes are different. Isothermal is a different process, adiabatic is a different process. But can we say that these two processes can become identical, means same? ये दोनों process same हो सकते हैं या they can be achieved under same condition. That same condition is absolute zero temperature. Absolute zero means 0 Kelvin. So at 0 Kelvin temperature, yes, you can achieve these two processes. Because if temperature is 0 Kelvin, then I don't think after 0 Kelvin, because it is not possible to even achieve 0 Kelvin temperature. But if it is 0, then it will definitely be constant and there will be no heat transfer at 0 Kelvin. 0 Kelvin पे कोई heat transfer नहीं होगा. The first Carnot engine work under temperature between T1 and T2 and the second Carnot engine under T2 and T3. Which is the following true for the above mentioned Carnot engine for same work output? Because we are talking about reversible engine, that is Carnot engine, right? And for reversible engine, if the work output is same, then T2 is equal to T1 plus T3 by 2. Arithmetic mean, the intermediate temperature will become arithmetic mean. This is called arithmetic mean. So what will be the answer? The answer is option B. So you can solve it. If you solve this option B, you will get T1 plus T3 is equal to 2T2. Are you getting the same value if you solve it? Yes. Next. Which of the following statement is incorrect? इनमें से कौन सा statement गलत है? Incorrect का हिंदी में मतलब incorrect का मतलब गलत होता है, but okay, those who are my friends who don't understand English, okay, इनमें से कौन सा statement incorrect है? Which of the following statement is incorrect? Is the cyclic integral. What is the meaning of cyclic integral? Integral and then put a cycle. Cyclic integral of Q by T. Q by T. If it is 0, the cycle is reversible. If it is less than 0, it is irreversible. Greater than 0, it is impossible. If the cyclic integral is greater than or equal to 0, it is irreversible. This is incorrect. All the other statements are correct. This is incorrect. ये गलत statement है. Cyclic integral Q by T अगर 0 होगा, if it is equal to 0, it will be a reversible cycle. If it is less than 0, it will be irreversible cycle. If it is greater than 0, it is impossible. but option D not correct. Next question is a question from entropy. 1 kg of air, which is having R is equal to 287, goes through an irreversible process between two equilibrium state. This is the equilibrium state. What is the change in entropy? First of all, we need to understand the equilibrium state. At equilibrium state 1, this is state number 1. So state 1 पे क्या हो रहा है? The temperature is equal to 30 degrees Celsius and volume is 1.2 meter cube. At state number 2, what is happening? The temperature T2 is equal to 30 and volume V2 is equal to 0.8. My dear students, I again want to remind you that in your RRB JE CBT2 and SSC JE CBT2, calculator is allowed. So please use your calculator. Okay, don't feel shy to use calculator. आप शर्माइए नहीं, calculator इस्तेमाल करिए. ठीक है? M CV log of T2 by T1. We'll use this equation because we have information about temperature and volume. So that is why we are going to use this equation. But those students who are smart enough to understand कि अगर टेम्परेचर सेम दे रखा है तो इसका मतलब T2 is equal to T1, that means log T2 by T1 will become equal to log 1, and that condition we can say log 1 is equal to 0, that means this will get cancelled, right? You can basically remember these steps. You can save your time. So directly we can put this value here, right? आप डायरेक्टली वैल्यू पुट करेंगे, आपका आंसर आ जाएगा. इन दिस पर्टिकुलर केस R इज गिवन 287, मास इज इक्वल टू 1, log of V2 by V1. V2 is 0.8, V1 is 1.2. Solve it, you will get the answer. Will the answer will come out to be negative or positive? Tell me first. See, positive value is not going to show up because log, if you divide a log where numerator is smaller than denominator, it is definitely come out to be negative. वैल्यू नेगेटिव आएगी, इसमें कोई शक नहीं होना चाहिए आपको. डेफिनेटली इट विल कम आउट टू बी नेगेटिव. आर यू गेटिंग माय फ्रेंड्स? समझ में आ रहा है? सो डोंट वेस्ट योर एनर्जी एंड टाइम इन गेटिंग मार्किंग ऑप्शन सी एंड डी. जस्ट सी ऑप्शन ए एंड बी. ठीक है? Now we need to understand one thing, that calculator is allowed. If you solve it, you will get option A, because as I mentioned, calculator is allowed. So option A will be the right answer if you do the calculation. Clear to everyone? Yes, everyone. Are you getting minus 116.36? Okay. Let's see the last question of today's session. आज का आखिरी क्वेश्चन. बाकी क्वेश्चंस अब हम कल करेंगे एफएम के. टुमारो वी आर गोइंग टू सॉल्व द क्वेश्चंस ऑन फ्लूइड मैकेनिक्स. वाटर फ्लोज थ्रू अ टर्बाइन इन विच ड्यू टू फ्रिक्शन देयर इज अ टेम्परेचर राइज फ्रॉम 30 डिग्री टू 35 डिग्री. इफ देयर इज नो हीट ट्रांसफर टेकिंग प्लेस ड्यूरिंग द प्रोसेस, व्हाट इज द चेंज इन एंट्रोपी ऑफ द वाटर? इस क्वेश्चन के अंदर ये कहा जा रहा है आपसे कि वाटर जो है वो एक टरबाइन में फ्लो करता है जिसमें फ्रिक्शन के कारण, ड्यू टू फ्रिक्शन टेम्परेचर वाटर का इंक्रीज हो जाता है. सो बेसिकली वी आर सीइंग राइज इन टेम्परेचर फॉर वाटर फ्रॉम 30 डिग्री सेल्सियस टू 35 डिग्री सेल्सियस, राइट? नाउ हाउ टू फाइंड द एंट्रोपी ऑफ वाटर? सी, यू नो दैट वाटर एक लिक्विड है. वाटर इज अ लिक्विड, एंड माय डियर फ्रेंड्स, फॉर लिक्विड वी नो दैट the entropy change is equal to mc log of T2 by T1. This is how you find the entropy change for a liquid. So आपको वैल्यू पुट करनी है. वाटर का मास तो दे नहीं रखा, कोई बात नहीं दे रखा तो 1 ले लीजिए. Cp आपको वाटर का पता है 4.18 होता है. log of T2, just put the T2 and T1 in terms of Kelvin. डिग्री सेल्सियस में मत पुट कर देना, तो ये हो जाएगा 303 केल्विन, एंड दिस विल बी 308 केल्विन. 308, 303. वेयर इज लॉग? हैव टू पुट द लॉग हियर आल्सो. आप लोग प्लीज सॉल्व करके मुझे आंसर बताइए. प्लीज एवरीवन सॉल्व इट एंड टेल मी द आंसर. This is the last question, but don't go anywhere. Tomorrow we are going to solve the questions on fluid mechanics. Okay? कल fluid mechanics के previous year questions करेंगे. Please everyone, do not forget to come live in the class at sharp 8. कैलकुलेटर को यूज करिए आप लोग. ओके, फॉर योर आरआरबी जेईई सीबीडी 2 you can use the calculator for technical part but not for non-technical. 0.0687, this will be the answer. Okay, well, for non-tech part, I don't think you will be getting calculation type questions, because in CBD 2 GK GS I don't think they will be numerical. For computer there will be no numerical. For pollution control there will be no numerical. तो CBD 2 में बेसिकली न्यूमेरिकल सिर्फ टेक्निकल से होंगे और टेक्निकल में आपका कैलकुलेटर अलाउड होगा. तो यू कैन यूज कैलकुलेटर एंड सॉल्व दिस क्वेश्चन, यू विल गेट दिस आंसर. Okay, so rest of the question we can solve in some other sessions. These are all previous year question. My dear students, if you have not yet subscribed to our channel, then please do it. And अगर आपने हमारा सेशन लाइक एंड शेयर नहीं किया तो प्लीज डू नॉट फॉरगेट टू लाइक एंड शेयर द सेशन एज वेल. Thank you so much for joining for this session. You can also join our Telegram Resultant. This is our Telegram Resultant A J Mechanical. Okay, so please join the Telegram. Thank you so much for joining for this session. Tomorrow हम लोग क्या करेंगे? Yes, I will share the PDF. Don't worry, I will share the PDF. Okay. Tomorrow we are going to solve the questions on fluid mechanics. कल फ्लूइड मैकेनिक्स के क्वेश्चंस करेंगे 8 PM शार्प. थैंक यू सो मच. हैव अ नाइस डे. विल सी यू टुमारो एट 8 PM ऑन द सेम यूट्यूब चैनल. थैंक यू एवरीवन. मिलते हैं कल. थैंक यू एंड हैव अ नाइस डे. थैंक यू सो मच.